Hello. Um, uh, I realized that probably I had a problem with my microphone. I just want to ask you, did you manage to hear me so far?
No.
No.
Yeah.
Okay. So let's start over from the beginning. So I deeply apologize for this. So welcome to the Antrea community meeting. Today is Wednesday, March the 16th. And in particular, I would like to thank the team members that are joining us from the United States, as today they are joining us at 10 p.m., which is quite very late for them, since they already switched to daylight saving time. And as a reminder, the next Antrea community meeting, when also Europe will switch to daylight saving time, will shift by an hour. This means that the meeting will not be anymore at 1 p.m. Beijing time, but it will move at 12 p.m. Beijing time, considering that China doesn't have daylight saving. So just keep in mind this, that for kind of for the next 6-7 months, the meeting will move to 12 p.m. China time. And so let's go directly to the agenda of the meeting, since due to my microphone malfunction, we already lost a couple of minutes. So without wasting more time, I would like to introduce the agenda, which is Hang providing us a presentation on Antrea live tracing. And therefore, Hang, please go ahead with your presentation.
Okay, thanks. So I'm gonna share my screen first. So can you see my screen and the design doc?
Yes, we can.
Okay, thanks. So I'm just gonna start. So today I'm going to introduce the design for live traffic tracing. So this design wanted to answer the following user cases, to support the following user cases. One is we want to trace the real traffic in Antrea. So not only just a craft packet or the first packet. And I want to give users the ability to configure their intentions by different sampling methods. For example, I want to sample first 15 packets or sampling the traffic at a given interval. So in the last, the user may want to traffic the trace in both directions. So this is the features we want to support in this design. So first, I want to give a few minutes to introduce what we have done in current version of the trace flow. So we Antrea's trace flow now support inject a packet into OVS and trace the real traffic for the first packet. So we can user can create a trace flow CRD and specify the type of this trace flow, and he will also he or she will also configure the source and destination of the packet. And when the trace flow session ended, so we will report the observations to the status field of the trace flow CRD. So the user can use the KubeSTL or the UI to start a trace flow session. And when the session ended, so the results will be presented by in the UI can be created by a graph. So this is the current feature our trace flow support. So this design has proposed real traffic tracing by capturing multiple packets. So we add a packet sample step in the normal trace flow session. So meanwhile, we can reuse the older OVS pipeline. So this is the basic design of our trace flow for real traffic. And after the trace flow session ended, we can use aggregated API to aggregate our results, because now we have multiple packets results. So it's not be enough to just use the trace flow CRD. So we can use the Kubernetes aggregated API to merge or aggregate all the results by a single API. So after this changes, our tracing session has different configures. So I have highlight the difference between our current version tracing session compared to the older one. So we have still use the source destination endpoint, the filter, and we still have a timeout field, and now we will have a new sampling config field. So here I have a simple example. So we have all our familiar fields, but we have a new sample field which has a type and a number. So our type means we want to capture the first unsampling, means we want to capture first 15 packets in this session. So this is the obvious change to the user. So he only needed to add this new config, and the trace flow session will start. So after this change, so we have a new step in our trace flow session. It happens very earlier before the OVS pipeline, means which is we will mark some packets based on this sample configure input by the user. So after this step done, all this marked packet will be processed in the OVS pipeline. It's pretty much the same as the older ones, but there are some small difference. So after this, next I want to introduce how we can actually do the sampling step. So we have a few choices. The first one is the TC sample action. So TC sample actions use the P sample kernel model to sample packets. So you can you can add a filter to the TC ingress or egress the Q disk, and after that you can add a list of actions. One of them is the sample action. So when after you add the sample action, the P sample kernel module will actually do the sampling for you, but it will send a copy of the sampled packet to the userland program. So you can get a copy of this packet. The next two choices are sflow and epifix. These are the sampling actions OVS support. So we can configure this sampling methods in OVS, but they only support for flow or bridge level metrics. For sflow, it can only gather the bridge level metrics and send to an external collector. For epifix, it can be configured both at a flow or bridge level. And after you gather the metrics, you still need to send them to an external collector. So these three choices, both they are not what we need, because we want to modify the sampled packet in place. So we need to modify the original traffic, and these solutions, they can only gather some metrics for flow and or send you a copy. So our last choice is using eBPF, because we can use eBPF to attach to the different host, different hook point to modify, to filter and modify the package. So we will dive into the eBPF solution and see what we can do. So here is a picture which will show how we can some of the most important eBPF hook point. For example, the one we want to use is eBPF, TC eBPF hook, because its position is stay just after the IP tables process and before we actually send the packet, before the NetDV process. So this is important because we need to make sure this program performs before the GSO part happens, so which will affect our choice for the packet mark, so which we will cover later. And over the years, the Linux kernel has provide multiple improvements for the TC eBPF. For example, it have specific kill disk called SAH, class actor, and a classifier called class BPF, and a new mode called direct action. It means you just need to use a single single BPF program, which can both do the filter and the action at one time. So you don't need to actually deploy two programs. First, one is doing filter and one is doing the action. So this is a huge performance improvement. And the data structure our program will deal with is SK buffer, because it contains nearly all the information we need for our package. So we still, for example, we can access the DSCP and the package mark and the IP ID field, which we will cover later, because we may need to use it as a packet ID. So this is the inside of our eBPF solution. So after we choose the underlying technology for the eBPF configuration, so we can support the following different types of sampling. The first one is sampling first unpackage. The second one, it means after we sampling the first unpackage, we can stop this trace flow session. The second one is we can sample one out of unpackage. It means we can count the packet, and after we unpackage, we can pick just one to mark it and send it to the OVS pipeline to be matched. So this is the most common configure, which has been supported by the TC sample action and SFlow and IPFix. The last one is a sample at a given interval. It means we can sample it for example, we can sample the traffic by 10 ms or 1 second, which is nearly rather rare choice. So each of this sampling method will have different parameters. For example, our first sampling, we need the user to provide a number, which means that the packet number he wanted to sample, and we need to enforce the number, the range for this number, because since we need to modify the original package, we don't want to bring huge performance impact. So we cannot allow the user to sample too much packets. So this is the number we need to design carefully to both match the user need and don't bring too much performance impact of our trace flow session. So we need to choose a max number for this parameter. The second tab is packet number sampling, which is we need a rate or we can name it as a number. So normally this number is pretty large. For example, most of the sampling configures supported by TC action or SFlow or IPFix, they have a number like 6555 36. So we can most of these numbers choice are the intentions are trying to reduce the performance impact. So the last tab we support is the interval sampling, which means we will have one parameter which defines what intervals the packs are sampled. So among these three sampling configures, I think the most important one is the first unsampling, because so when you can capture a series of packets, these packets are more related than the other two sampling types. For example, we can capture a single TCP sessions package if you can specific proper number. For example, we have a rough guess. For example, we have 15. For we can set the number to 50. We may capture a whole TCP sessions packet, and this can be pretty useful for most of the user cases. So, and for the interval sampling, we still need to remember one thing, that we have a timeout field in the trace flow session. So both the packet number sampling and the interval sampling and the first unsampling, they will have a hard limit, because we have a timeout field in the spec field. So both this sampling method will be ended if at a reasonable timeout. So this is the description of this 3 sampling configures. So after adding this sampling configure, our trace flow status field will still be used to aggregate the result of the first packet. If so, there are 2 cases. First, we can still use the trace flow as the old ways. There are no sampling configures, and nothing will be changed. And if the sampling configure present, we can still report the result of the first packet, but we also need to aggregate the result of other packet to different places. So to the users, most of the interface will stay the same, but we add a new interface or API to provide the different result. So in the packet sampling process, we still need the DHCP field we already used before to acting as a data plane tag. And besides that, because we are capturing multiple packets, we still need a unique ID field to correlate the captured packet, because we may have a different hosts and different packets. So we need to capture them at a different checkpoint. So after the session is ended, we need something to merge to correlate the results. So we need a field to acting as the unique ID for the packet. So I have present 2 solutions. The first one is a packet mark. This is an internal packet field in the kernel, and we can carry it in the Geneva option on the where. The second one is IP ID, which is internal, which is the standard field in the IPv4 head. So the preferred solution is using IPID, which I will explain why later. But first, I want to share the packet mark solution. So this field is an internal field in Linux kernel, and we can use it to match the different bits in both in OVS or IP tables. And Antrea already used some of this field for the egress scenario. So we still have the remaining 24 bits which can be used to acting as the packet ID. So when it's on the where, we can use the Geneva option field to store this packet ID to carry it to different hosts. So this will need MTU change because we have increased the space, the total length of the packet. So this is the main drawback of this solution. And the next choice we have is IPID, which we preferred because it's already in the IPv4 head, so we can after we can figure out what is normal usage, and to avoid the conflict between the between the normal intention. So we can use this field carefully, even it's very even this is the public field. So I have a list most of the cases which we may need to consider. The first is this field has been clarified by the latest IFC to should be only used for fragment and assembly. However, over the years, this field has been used for different cases, and different operating systems tend to set different values for this field. So I have a little research, and we have list the different possible values for this field. The first one is global counter, means each time when the OS sends a package, it will increment this field. The second one is a local counter. It means for different destinations. So each time a new package is sent to this destination, so this field will be incremented by 1. There are random numbers and constant values. In constant values, it's usually its value is 0. So so this field can be set by different algorithm, and its value can be vary for different situations. So we need to figure out all the situations for it. So so I have actually captured multiple packets from different OS and verify the values distribution. So most of the cases is a local counter or global counter, which means each time you capture a package, after the new package will be the new package's IP-ID will be incremented by 1, and most of the other half the cases its value is 0. It's the random number is a pretty rare case, so we can ignore it for our design. So there for different traffic, for example TCP, since we can use PMTU to figure out the actual MTU for our session. So the don't fragment bit is always set, means this packet does not need to be segmented. And in this case, the ID value in this packet should be ignored by all the device and the destination. So we can set this field safely in this situation. So for UDP traffic, it can be as a case for the DF bit, because different OS tend to choose different approaches. So you can see that some of the packets for the UDP traffic is set to the DF bit is set to 0. Some of it is set to 1. So we need to deal with both the situations. Besides the TCP and the UDP traffic, the GRO and the GSO process also will affect the IP-ID field. So for example, we have multiple packets come from the same flow, and the GRO may choose a protocol-specific algorithm to merge these packets. The different protocols will have different algorithms. So for the TCP case, the 2 packets can be merged only if they belong to the same flow and they have the TCP flags. For example, the SEQ field, and they need to have the same DSCP field, and their IP-ID field should be continuous, which means usually it's 0 or continuous, which means you should be increment 1 by 1, and constant, which means it's always 0, and the DF don't fragment flag should be the same. So since we have used the DSCP flag to be the data plane tag. We have set this field. So our sampled packet won't be accidentally merged by the GRO algorithm to be with the ones that don't have the DSCP field set. So so we have the DSCP field and the IPFD field. They both can help to confirm that our sampled packet will still be stand alone. So when we receive it, so there are still some risks. We'll cover it later. And the final case is for IPv6, since IPv6 its ID field is different from IPv4 because this ID field will only exist after the packet is fragmented. So normally you cannot assumption that this field is always exist. So if we choose the IPID choice, we don't have the support for IPv6. So considering all the above cases, we can still use this field to aggregate our trace flow result. There are two main cases. The first one is this field can be 0, which means the DF bit is set and all the devices and the destination, it cannot rely on this field. It cannot rely on this field to perform actions. So we can set this field to a random value. So we know that we can use it to correlate the target packets. So if this field is not 0, which means it's already a flow counter or global counter, so we can reusing the existing value. So there are still some risks. For example, we need to carefully choose an IPID, which we won't conflict with the existing ones. The second possible risk is if packet loss or packet delay happens, which means the GRO algorithm may be failed. So in that case, we can still report what we have got at the packet in message, because we may have got some partial result from the sampling packet. So we don't have much to do with these circumstances, but we can report the results we have found. This is the packet mark section we have considered. And
Hang, I have a question here. So, yeah, I think you talk about more the cases, so I'm not sure I'm following, but I trust you did the complete analysis here. But it still sounds very tricky, right?
Yes,
is that
sure.
Is that just our invention, or any other solution also use this field to do something similar to us, basically to trace the packet?
So I think the most suitable choice is besides the IPID is still the packet mark solution, because it's a field to be used as a mark for this package. And
basically my question is, do we know any other solution that also use IPID to encode some ID into the packet, or it's just you? I don't know how you come with this idea. So it's like
So there are many cases to use this field to do some research, but I think modifying this package is not quite common, because I have seen some research to read this value as a matrix to find out for example, they can be used to find how many backend servers behind LB service or behind an NAT. So this field is a useful metrics for many cases, but I think modifying this field is it may be still common for the early days, but in today's, so this field has been as I said before, this the latest RFC has clarified this user field should only be used for segment. So I didn't see any research or programs to reset this field. And however, I have seen some research to some draft RFC draft to they want to extend this field to be used for other purpose, because we still have some other flags in the IP header is still reserved, and we can combine these flags and this ID field to be used for other cases. So it's not very common, but it's still a possible path for even for the community. And we only change this field value when it's 0. So my point is it can be still be risky, but I think the impact can be, it's not that big. So so I think that's my point. Oh, okay.
Another question is for the low income mode. Do we know any chance the router or any device in the underlying network can drop the packet if we set the IP?
No, because if we set this field, if we set this field, it means its original value is 0, which means the device it cannot segment this packet and will ignore this field for all the behaviors, for all the possible cases. So I think it's pretty safe to set this field only if we our value won't conflict with the existing sequence, the ID sequence.
Okay.
So after we carefully choose our packet mark solution and we use the DSCP field to be the data plane tag, and we still using the packet in message to report our observations, and we can get the result for our captured sampling packet, which is multiple. So we need to the first result we can get is different from the current trace flow session. We can capture the result package and store it on the local cache first, because we now we not only have the trace flow path for not only a single packet, we can get the trace flow path for each of this packet. So we can capture and store it on the source endpoint and the destination endpoint for the destination endpoint for each node, and we can store this packet in the pcap ng format, which can we can also record the extract IP ID field in the comment section of this pcap ng format, and we can also record the trace flow path in this comment section. So after we gather all this captured raw package, and we can use the aggregate API, just like we have done that before, the support bundle API, which the user can use the anti-CTL tool, or we may have a new button for the UI, so we can allow the user to download the captured package, and this package can be reviewed on their local GUI tools such as Wireshark. And so I think this is pretty convenient for people to analyze their traffic in their preferred ways. So besides that, we can also analyze this package and provide some extra details or list metadata. So we can get the packet metadata from all the package, and we can get the packet ID, the protocol, the size, and we can analyze this package and use extra storage, or maybe we can use the EGCD or CRD or local cache or in-memory to provide extra APIs to present this analysis package metadata, and we can provide extra API or UI diagram to the user. So this can be done at if we want to. So, but with the designs, but for this APIs, we need some extra design for the storage, because we can't store the package raw data in local cache, and the metadata or part is tricky because we need to store it on some different places, because we want these results can be retrieved by real time. So we don't want the user to wait for a long time for the API to respond. So this is the aggregated API part, and we still have the other thing I want to, which we can do, is the biodirection sample, because we in the case if our destination is a port, so we can install the API program on the destination TC hook point and sample the traffic in both directions. So this won't be very hard, because we can reuse most our API program and our TraceFlow pipeline. So and I think this will be very useful for the real traffic tracing. And so after all these changes or this design have introduced, we have now our TraceFlow workflow will becomes first the user will create a TraceFlow request using the CRD or our CTL command tool. So after this TraceFlow session is created, and we will, if it will contain sampling configure, we will deploy our eBPF sample program to the target TC hook point, and this program will start to sample the package and mark the package. So after this sampling action started, our live traffic result will be reported by our OVS packet in message. So after we get the packet in message, part of the trace result, because we still want to report the result of the first packet to the TraceFlow CRD, and the captured package for other packets, for all the package, will be saved on localhost and will be aggregated by Kubernetes aggregate API and will be served to the user. So this is the total over workflow for our new TraceFlow session. So I think that will be all, because I have covered the future work, something we can done later, because we the last part is we can add some UI pages to represent the package we have captured. For example, a download button for the raw packet data, and some pages or diagrams for the package metadata and packet list metadata. So I think that will be all. I have created an issue on the Antrea GitHub. So, and I have attached this document in the comment section. So thanks for, if you have any comments, and we can talk about it now, or we can talk about it on the GitHub link.
Thanks a lot, Hang. This was a great presentation with a lot of information. To be honest with you, I have some curiosity, some questions, but I still have to wrap my head around the presentation. So I will probably comment on the document. My only question is about filters. You know, when we inject a packet, typically we know what we are injecting in normal trace flow. Now we are injecting, when we do live sampling, we are still honoring all the filters on source, destination, packet, and like a source port, destination port. That's just my curiosity. If basically we are going to monitor only live traffic that matches the conditions specified here, or when instead we are going to monitor all the live traffic. I think we are still only monitoring traffic between source and destination that matches the characteristics that we see here. Is that correct?
Yes. So we only need to monitor the filter. We still have the filter to restrict our trace flow session to the target flow, not on all the traffic.
Yeah, in this case, are you going to install the filter in the eBPF program? Like, is the eBPF program that will only inject in data matching the filter, or are we doing filter like in normal trace flow?
Because we have the program acting before the OVS pipeline, so we need to make sure the eBPF program still do the filter, because it will still be very easy, because we can't get all the filter information from the raw packet. So we need to filter the target packet in the eBPF program and mark the target packet. So I think this part is essential, and it still be needed in this part.
Okay, thanks. So this leads me to the final question that I have. It's probably very stupid. Since this filtering is done before the OVS pipeline processing, when we have this destination matching, this means that if the traffic is directed towards a service cluster IP, we don't need to match on the pod IP, but we need to match on the service cluster IP. Will that be correct? Because the NAT did not occur yet, because NAT will occur in the OVS pipeline then.
I think I have not considered this this situation when the target is a service IP. So I may need to have a clear look at this part first, and I think I may need to consider this situation carefully after this today's session. Okay, thanks.
But to be honest, it's yeah, go ahead. It's not important. That's what I say. Yeah.
So thanks for pointing it out. I think I have missed this case.
But even just doing pod to pod will be just great as a starting point. Then adding support for service class IP can be done later.
Sure.
Okay, so thanks. That was my only question. And then I think that if you wanted to restrict the ability of doing trace flow, that's everything that's just stuff that we can control using Kubernetes Airbag, because the only additional thing here is that since we are monitoring live traffic, there could be a privacy concern. So I don't know if we want to make I think it should be possible to say that have some restrictions in terms of Airbag, in terms of the users that can do live traffic filtering. This is like, it's just because I love to be pedant, but since in this case we are monitoring live application traffic, there could be some privacy concerns in users, and so you want to restrict the ability of doing live tracing, like only to the owners of the applications or to admin users?
Yeah, I have considered this because we have modified multiple packets, so at least we need to add some document for the user. So say that we have, if you enable this feature, we will have to modify this field and this field in your real traffic, and you should use this feature in caution, and you should be aware of the changes we have made, because we have already modified the first package. So I'm not sure if a new document will be enough, or we may need some other materials to cover this case.
I don't have a strong opinion. Just yeah, maybe documentation will be enough. Yeah. Okay, so thanks. Sorry, I don't have any other question for the moment. Thanks a lot for your answers. Is there any other question from the community?
Yeah, Han, actually, I have several comments. I'm not sure we can talk about in this meeting. But overall, first, I feel the tracer is a little overloaded. I kind of feel probably we should use another CRD in my mind.
I don't think we need a new CRD, because we for now we only need a new aggregated API to just
no, I understand. I just mean from user perspective, I feel probably we don't need to mix packet capture and sampling into the trace flow. That's my feeling.
Okay.
Because sounds like your most of your, I mean, its feature is more for sampling and packet capture, right? I'm still trying to understand why we need to trace the first packet together with this feature. I think they are kind of independent information in my feeling.
So I think create a new CRD is totally acceptable for us to just for the sampling, and we can call it a live trace flow or something. So I think this is just a different choice, and we can create a new CRD for this this trace flow, this new kind of trace flow.
Sure, I think it's just my personal idea. Probably we can also discuss more here, and then we can hear others' opinion. The second thing that yeah, I'm still trying to understand. I mean, do we need to be so complicated? Like we need to add a tag into the packet, so we capture the packet under two sets, or we can just capture the packet under source or destination. We just choose one, then we don't need to.
Yeah, I think this part is also can be discussed, because we can only capture the packet at the source endpoint, which will provide a pretty much useful information, and we can also choose to capture them at both the source and the destination. I think these are not final choices, because we can do for either case, or we can do both, because we have the ability to do so, but it does not mean we have to do all these captures.
Exactly. Probably my last one is that yeah, probably I need to understand the eBPF thing, like how much complexity it is. I mean, how much code we're adding. If it's too.
I think since we have already done some research on this part, I think this this program will. I don't think it will be for too. It will be too large, because the ecosystem for TCP/BPF is pretty mature, and we have all the things we need to. For example, we can directly access the field, and we can directly get all the field we need by the supporting of the lib eBPF libraries provided by the kernel. And I think the most complex part is to choose a algorithm for the IPID value. So besides that, I think the most other parts is pretty trivial for us to implement it.
So you want to have a POC, or it's like?
I don't have now, but I don't think it will require much effort to do so.
Okay. Anyway, I just feel probably we need to do a evaluation here. I'm just concerned. I mean, if it's lots of code, then it can be overkill. And also means we need to maintain, some additional code, especially with the new technology. That's my only concern.
Yeah, I understand this consideration.
Okay,
So,
that's all my comments.
Thanks a lot, Janjun. I managed to mute myself again without realizing it. Sorry about that. Is there any other question from the community? Any other curiosity? Okay, so Hang, the only last favor that I would like to ask you, if you can share on the chat the link to the GitHub issue.
Sure.
Yeah, so that we have a trace of it. 3428, that's great. And so that everyone can go there and leave comments on your proposals, which is
So I have this doc pasted in here. This anyone can view this Google Doc.
Awesome, that's great. Thanks a lot. And any other question? Any other topic you would like to bring up for today? Waiting a few seconds. All right, it seems that we are at the end of this meeting. So for the next meeting, we'll be back as usual on Monday evening for folks in the US, Tuesday for folks in the rest of the world. As we already announced, the only difference is that now with the daylight saving starting also in Europe, the next meeting will move at 12 p.m. Beijing time, and it will stay like this until the end of October. All right, thanks everyone for joining. I'm going to stop the recording now, and I wish everyone a good evening, good night, a good morning, or a good afternoon.
Thank you, everyone.
Okay,
thanks for
Bye.
good question.
Bye.